2.6, Proving Statements about Segments and Angles. In this lesson, we're going to use deductive reasoning. A proof is a logical argument that shows a statement is true. There are several formats for proofs. In this class, we're going to be focusing on the two-column proof. And as I go through the lesson, it will make some sense. So first, we're going to look at a warm-up exercise so that we understand properties. This is the property of equality to complete the statement. So if the measure of angle 1 is equal to the measure of angle 3, then the measure of angle 3 is equal to the measure of angle 1. And that is, to make sure that you know these, the symmetric property of equality. For the next one, if AB is equal to CD and CD is equal to TU, then AB is equal to TU. That's the transitive property of equality. If RS is equal to WX, then if we have RS and we add AB, and we have WX and we add AB, we're using the addition property of equality. If the measure of angle EFG is 28 degrees and the measure of angle GFH is 62, then we're going to fill in here with 38 plus 62 is the measure of EFG plus measure of GFH. In this case, we're substituting. So it's substitution. It's not substitution property of equality. You're not doing the same thing to both sides of the equation. Okay? It is difficult to read this problem, so I am not going to do this problem, and actually it is example 4 in lesson 2.5, so we worked on it in that lesson. So in this one, we're given 4 steps of a proof as shown. We did this in class today, but going through this, I know I wrote it, I'm going to write it again. The first statement you're given, the reason is always given. If I asked you to do this from scratch, which I'm not going to do, your first statement is always the statement that you're given, your reason is always given, and what you're proving is always your last statement. So, if we are doing a proof from scratch, you might look at this and say, well, I'm trying to prove that AB is equal to BC, and so I realize that maybe B is a midpoint. But you're not being asked to figure out how to prove this. We're just asking you to come up with the reasons for the work that has already been done for you. So there's a few things to do. First off, when you are trying to figure out a statement, look at what you've done previously to see if it's something based off of what you've done previously. So this next step in this proof, I'm actually going to look and see where they're trying to get this statement AB plus BC. Well, I can see that there's an AB here and AB here, but I don't have anything yet in the given that shows me that I can just substitute BC for AB. So I'm going to look back at the drawing. And I see that they're talking about this entire segment AC. And I can see that this entire segment AC is actually made up of AB and BC. So when I take AB, I add the length of BC to it. I get something that equals the total length of AC. That is the segment addition postulate. Now in the next step, AB plus AB equals AB plus BC. Well, looking from number 3 back to number 2, I don't see anything just directly in number 2 that leads me from 2 to 3. I also, looking at the drawing, don't see an AB plus AB. I do see an AB plus BC, but I don't see an AB plus AB. What I do see, though, if I look, is I see an AB plus AB. And I see that in the first line given. And then I also see AB plus BC, AB plus BC in the second line that we came up with the segment addition postulate. And I notice that the two other things are AC and AC. So I have a number of things here that are all equal to each other. I have a way to represent that AC, AB plus AB, and AB plus BC are all equal to each other from the steps above. But what I do see is, since they're all interrelated, it's like a giant law of syllogism. And when I use this law of syllogism, that is transitive property of equality. And then once I'm able to use transitive property of equality, for number 3, I can look here and I can see that statement 3 was AB plus AB. Another part of the statement was AB plus BC. So this BC is that BC here. This AB is this AB here. And I see that both of these up in statement 3 had an AB term, and they don't have it here. So I'm actually subtracting AB from both sides. When I do the same thing from both sides, it's subtraction property of equality. And those are the reasons associated with the statements in this proof. And if it's hard to see everything here, I'll go ahead and wipe this all off so that you can look at just the 1 through 4 reasons. In this lesson, the book also talks about some theorems. I already talked about these in class the other day when we talked about reflexive, symmetric, and transitive properties of equality. I said you could also have reflexive, symmetric, and transitive properties of congruence. So that's actually what you would use. We're going to go through some examples. I'm also going to make a quizzes for us to do it, and that should help a little bit. So let's look at some examples. If angle R is congruent to angle T, and angle T is congruent to angle P, then angle R is congruent to angle P. Just like in properties of equality, this is transitive property. If one thing is equal to another, and that thing is equal to a third, the first one and the last one are equal, it's the same thing with congruence. So it's transitive property, and we're talking about congruence. In this second one, if line segment NK is congruent to BD, then line segment BD is congruent to NK. We've just switched the order of what's on either side of the equation. They're still symmetrical. So that is the symmetric property of congruence. Let's look at these two. In this one, it's CD, line segment CD is congruent to line segment CD, so that's reflexive property. And since it's a congruent symbol, it's of congruence. Angle Q is congruent to angle V, then angle V is congruent to angle Q. That is symmetric property of congruence. For this next problem, this is a guided practice, and we did not do this one in class, but I'm going to walk through the steps here. So what I did to walk through the steps is I copied the given and the proof. And then let's look. M is the midpoint of line segment AB. So M is the midpoint of line segment AB, and that's given. So my first statement is always what I'm given. My first reason is always the word given. My last statement is always what I'm asked to prove. They actually say two things here. Part A, we're going to prove that AB is equal to 2 times AM, and that AM is equal to 1/2 of AB. So I'm going to get to this because there's a little technicality there in that they have it written in a different order, but we'll talk about that in a minute. So if M is the midpoint of AB, then I know that AM is congruent to MB. And I know that because that's the definition of what a midpoint is. A midpoint is a point that divides a segment into two congruent parts. So you're using that word midpoint and explaining it. Okay? Now you'll notice that this proof starts dealing with equal signs. Okay? So for an equal sign, we need to change from working on congruence, having congruent symbols, to having equal signs. So if AM is congruent to MB, then also AM is equal to MB, and that's basically the definition of congruence. If something's congruent, it's also equal to it. Now, if you were doing this as a proof from scratch, and you did not have this, and you did not have this, okay? And you wrote AM is equal to MB and the definition of midpoint, at this point I would accept it as correct. The reason that we do a skeleton proof is because technically a midpoint definition doesn't say that it's dividing it into two equal parts. The definition actually says it's dividing it into two congruent segments. So we have to get from congruence to equals. I know that seems a little obvious. When it's written there, I want you to be able to come up with the reasons. So after they get through the fact that these are congruent and they're equal, they go through the point that AM plus MB is equal to the entire length. And that's the segment addition postulate. Okay? Now, since I said that AM is already equal to MB, I can take out that MB and substitute it with AM. I wouldn't use property of equality. It's just you're using substitution here. Okay? Now, I also have a little bit of an issue here. You are not distributing here. So I don't like that. You are combining like terms. Okay? And after you combine like terms, technically, to get to this, which is AB equals 2AM, you would actually need to do symmetric property of equality. I differ with the book on how they would do this to make it a true proof. Now understand, at this point, we're just putting in steps into skeleton proofs. Even on the EOC, there will be proofs that you must say, well, I think they kind of missed a step. You're not fixing their errors. You're just going with giving the reasons for what they put in. So to technically do this proof, to get from here to what you wanted to prove, you need to flip it and put symmetric property of equality. Now, after that, they said, what if we take it a step further, and after symmetric property of equality, we wanted you to end up with AM equals 1/2 of AB. In this case, you're dividing both sides by 2, so you have the division property of equality. So as you kind of see, writing a 2-column proof is a process. And just some things we talked about, you always have statements on the left, reasons on the right. You number them. The first statement goes under your first statement and the reason for it is given. What you are trying to prove is always going to be your last statement. Okay? These are going to be using deductive reasoning skills. And here you're going to list definitions, postulates, or proven theorems that you allow you to state the corresponding statement. In this class, we will actually go through and practice proofs on proving theorems. But if I give you a theorem and we've learned it, you can use it in a proof. You don't have to go through all the steps of proving it every time you use it. Now, this problem is in the book. There's a typo there. It should say, don't do this one. Instead, we sound like a Rihanna song. Don't do this one. Don't do this one. Okay? This problem, though, I think gets much more confusing than we need to be at this point in our learning. So I don't want you worrying at this point about this proof. Okay? I am going to go through this proof. I did it with you in class, but I don't like the way it lays out here. So I'm going to actually work on it in an order of how I would actually do it. Okay? So I would actually start with the first thing, MA equals TH, okay? And that is given. Now, if MA equals TH and I'm trying to prove MT is equal to AH, I can see that MT and AH are made up of a series of smaller segments. So that immediately in my mind says to me I'm probably going to be using segment addition postulate. So if I said that your second reason was segment addition postulate, hopefully you would be able to then say, okay, well, I'm going to eventually prove MT and AH. So the segments that make up MT are MA plus AT. Okay, that equals MT. And AT plus TH equals AH. That's segment addition postulate. Now, just looking at what would work well, trying to decide what would be next, okay? And I would actually give you the statement, you're going to fill in the reason. But I see that since I want MT to be equal to AH, if there was a way to say that MA plus AT was equal to AT plus TH, if I could show that somehow, that's going to like fit really nicely because then I can take those ATs away. So I'm just going to put that here and say, is there a way to show it? Well, here I have MA and AT. And up here I have TH. So if I have MA and I add an AT, and I have TH and I add an AT, that's going to be MA plus AT. And maybe I would have written as TH plus AT, but the order doesn't matter. Okay? And actually I'm doing the addition property of equality. I'm actually back to my first step here, MA and TH. And I don't know if you can see that there, but I'm just adding an AT to both sides. Now, if these ATs that I just added, right, have those, I want to get to MT and AH. Well, MA plus AT is the same thing as MT. Color code that. Oh, I want to color code that, not knock it out. That was MT. And AT plus TH is AH. Color code those, different color. Oh, my pen. Highlighter's not working. That's AH. Okay? So I can start to see here that I have lots of things that are equal to each other. And when I have a bunch of things equal to each other, I'm probably dealing with the law of syllogism. MA is equal to MT, right? And MA plus AT is equal to AT plus TH. So this is equal to this, and this, and this. Everything's equal to each other. That is the transitive property of equality. In class, they also added another step that AT was equal to AT by the reflexive property of equality. I don't think you really need it in this proof. If they have it listed there, let's just say they have this listed there, and you say, well, I don't think you really need it, still, can you define the property? Yes, it is reflexive property of equality. So you can still define or give a reason for what that property is. I'm going to do another one. This one has the statements here. We're going to fill in the reasons. So the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. And the measure of angle 1 is 59 degrees. That's given. I could have done this in 2 steps. They could have listed measure of angle 1 plus measure of angle 2 is equal to 90. That's given. And then the second step, they could have listed measure of angle 1 is equal to 59. That's given. So now for this next step, the measure of angle 2 is equal to 90 degrees minus the measure of angle 1. What they're doing here is they're taking just this statement and they're isolating the measure of angle 2, and they're doing that by subtracting the measure of angle 1 from both sides. So that's the subtraction property of equality. Then they are taking the measure of angle 1, and since the measure of angle 1 is 59 degrees, they are taking out the measure of angle 1 and they're just putting in the 59 degrees. That is substitution. And for number 4, some of you are just going to say, you could say simplifying, or combining like terms. Because the 90 and the minus 59 are like terms. Now you're combining them. I hope that helps you. That's a number of proofs we've gone through. I hope that helps you. And you should now be able to do your homework. There's also some other problems you can look at. In class next week, we are actually going to be given all of the steps to do these 4 proofs. We're going to have to put things in the right order in order to do the proofs.